Okay, so today's your first day of lessons. For this to be effective, you need to take notes. I will clarify what part you need to write down, but for the most part, you need to be taking adequate amount of notes and following and paying attention. So today's lesson is Chapter 5, Lesson 1, Polynomials. Everything we do from now until the end of the year is going to get you ready for algebra, because that's what you're taking next year, and I want you to be successful. So your objective is to define a polynomial, to classify a polynomial by the number of its terms, and to simplify polynomials. So suppose you worked at the school supply store. Students email their supply orders to pick up before or after school hours. The details of several students' orders are summarized in the spreadsheet below. Write an expression to represent each student's order. So I'm going to apologize in advance for my handwriting on an iPad. So my customer is Leon. So if I look right here, second column, so Leon, he bought 3 notebooks. So we don't know how much the notebooks cost, but we know that there's 3 notebooks. He bought 1 pen, so that would be plus 1p. And then he don't buy any rulers or any calculators or any binders. So that is his, that's what he bought for his order. So let's go on to the next one. So Siobhan bought 4 notebooks, no pens, no rulers, 1 binder, and 1 calculator. Okay, and then the next one, Joseph, he bought 2 notebooks and nothing else. So, what's the point of this? I'm trying to show you different types of monomials and polynomials. So I wanted to give you a real world example of when you would actually see them. So the expression 2n is a monomial. So I'm going to go on. The definition of a monomial: it's a polynomial with just one term. Well, that makes total sense. It's mono, one term. So, but what is a polynomial? An expression that can have constants, variables, and exponents that can be combined using addition, subtraction, multiplication, division. But these are important for you to know. No division by a variable. A variable's exponent can only be 0, 1, 2, or 3. And those ... means they can only be positive numbers. That means it goes up. And it can't have an infinite number of terms. Okay, so here's an example. All we're doing today is classifying polynomials, not polynomials, and monomials. So here's an example of a polynomial. A polynomial, this is an example because it's not dividing by a variable. There's no division. A variable's exponents can only be positive. They're all positive. It can't have an infinite number of terms. There's not an infinite number of terms, and it can only be combined using addition, subtraction, multiplication, and division. I only see addition and subtraction, and I also see multiplication between the terms. Well, when we did combining like terms, we counted, and I remember in class you were like, oh my gosh, that's so easy. That has 4 terms, that has 3 terms. Well, this has 4 terms. Terms are separated by adding and subtracting symbols. This is an example of not polynomials. Okay, so this should be written in your notes. I'm going to go ahead and I'm going to talk to you about this little chart right here. Just kidding, I'm not talking about that chart. I'm going to talk to you about that chart after I get done with this next slide. So, which of the following expressions are not monomials? Explain why each is not a monomial. A monomial is a polynomial with one term. Here we go. And this is what a polynomial is. Just a reminder, this should be written in your text, in your notebook. So I want you to go ahead. Which of the following expressions are not monomials? Well, is A a monomial? Yes. R is a monomial. Is B a monomial? Yes. B is a monomial. Is C a monomial? No. You should have said no. No division by a variable. So C is not a monomial. Is D a monomial? Yes. Is E a monomial? All of its variables are exponents. It's not dividing by a variable. Yes, it's a monomial. Is F a monomial? Nope, and yet again, there's a variable. It's dividing by a variable, so F is not a monomial. Is G a monomial? M-N-O-P. Yes. G is a monomial. Is H a monomial? No. No, it is not a monomial. Why? Because the variable exponents can only be 0, 1, 2, or 3, and goes up. It doesn't go down. Basically, that says the exponents can't be negative, and H has a negative exponent. Okay, so classify each expression as a monomial, binomial, a trinomial, or not a polynomial. A monomial, binomial, and trinomial. A monomial is a polynomial with one term. A binomial means two. It is a polynomial with two terms. And if you notice, none of the exponents are are negative. These commas are separating them. That means these are examples. 3b plus p, 2x plus 8, 2a squared minus 6b squared. And none of them are being divided by a variable. A trinomial is 3. So 4nb plus b plus c, 2x squared plus 8x minus 3. Okay. So I want you to copy A through H in your in your notebook. And then I want you to pause the video and see if you know which ones are monomials, binomials, and trinomials, or not a polynomial at all. Alright, so you should have paused it. So A, x squared minus 49. Well, first off, is it a polynomial? Yes. The exponent's positive. They're not dividing by a variable. So A is a polynomial, but what kind? There's two terms. Terms are separated by adding and subtracting. So this means that it is a binomial. Yes, spelling matters. You have to spell correctly. B, the square root of 3mn plus n cubed. Is that a polynomial? Yes, it is a polynomial. It is a binomial. And again, if you have questions and I don't clarify something for you, go ahead and write them in your notebook, and then when you come into class tomorrow, I will gladly answer them. C. Is C a polynomial? Exponents are all positive. There's not dividing by a variable. I'd say that that is a polynomial. But what kind of polynomial? Is it being separated by adding or subtracting? No. I know that there's one term, so it is a monomial. Okay, D. X plus 1 over x plus 1. It is being divided by x plus 1, which is, there's a variable in there, which means that this is not a polynomial. So, not a polynomial. It is nothing. Okay, E. 1/2 b plus 1/3 b squared plus 1/4 b cubed. Well, 1/2 b plus 1/3 b squared plus 1/4 b cubed. It's not being divided by variable. All the exponents are positive. It's not a not repeating number. So E, I would say, is a polynomial. What kind? Well, there's 1, 2, 3 terms being separated by addition. So that means it's a trinomial. F, 19, that's a monomial. That's a polynomial. G, being divided by variables, so not a polynomial. And that's not going to let me write over my face, which is not cool. Okay, and then H, all of those are positive exponents. There's no repeating numbers. I would say that's a polynomial, and it's being separated by a minus and addition. Subtraction and addition, and there's 3 terms, which means it's a trinomial. Alright. Write each expression as a polynomial in simplest form, then classify it. So, to do this in the simplest form, if you notice that there's these parentheses right here, which means you're going to have to do the distributive property, your favorite. So you're going to have to distribute, which means multiply, x times 3, which is 3x, minus, take your minus sign down, times x, which is x squared. Now, is it a polynomial? I've done it as the simplest form. And then classify it. Is this a polynomial? Yes. What kind? There's a minus sign that is dividing 2 terms up, so that means that this is a binomial. I want you to go ahead and pause it and do B and C, and then we'll see how you do. Okay, so B is, I have to combine like terms, 4a minus 3a minus a. 4a minus 3a is 1a, minus a, so I have 4, I'm going to go ahead and show you it. So 1a minus a plus c is what I'm left with. A minus a goes away, 0a is just 0, so then I just have c. Is c a polynomial? Well, yes it is, and there's only one. It's kind of obvious, it's a monomial. Okay, so now I'm going to go ahead and do the next one. 1/3 x squared is negative 1/3 x squared. Negative 1/3 times 6xy is, negative 1/3. 6 divided by negative 3 is the same thing. So 6 divided by negative 3 is minus 2 xy. And then plus 2/3. I ran out of room. 1/3 x squared minus 2xy plus 2/3 y squared. Now, I skipped a few minus and adding steps, but this is what you should have got. And even if you got the wrong minus and plus signs, we can go over that tomorrow. The most important thing is that you can recognize if this is a polynomial or not. And it is. And then there's 3 of them, so it's a trinomial. Oops, I spelled it wrong. Trinomial. Okay, I want you to just do number 6 and number 7 to the best of your ability. And tomorrow when you come into class, we're going to see how you did. It's important for you to try it because you need to know what you can do on your own.